I want to talk to you about a topic called DNS tunneling. DNS tunnels can be used to avoid paying for services. They can also be used to take data out of a network and bypass lots of corporate policies and firewalls and other techniques. I've personally witnessed VoIP packets being sent from a Latin American country back to a European country without the hacker paying for them. And they were selling a service to customers in that particular LATAM country. And the mobile operator was losing north of 50,000 euros a day in peering costs. So this is a very expensive problem. Now the Secure64 platform can automatically detect DNS tunnels. We don't rely on a list. We work out that the transaction is a DNS tunnel and block it automatically. The 4 screens that you can see are a way of showing this in operation. So the top screen here that's red on the left is the tunnel server. It's running on a Raspberry Pi and it's running a platform called Iodine. It's free of charge. You can download it from the internet and it has a server and a client component. I'm running the server on my Raspberry Pi. The client is running on my MacBook, but equally you can get clients free of charge from the App Store and Play Store and run them on your mobile phone, and it costs you nothing. I'm going to demonstrate this in action via these 2 screens here and this 3rd screen where I'm going to show you the fact I can send data from A to B. The white screen here is my Secure64 server. Now to demonstrate this in operation, I've actually disabled some features and I'm going to show you and prove you that, and then I'm going to enable them, and after a second or 2 the tunnel will be detected and blocked automatically. And you'll see this with the refused command that comes up on this display here. So watch out for that. You'll also see the pings that I send across will be blocked automatically. And then lastly, I'm going to show you some of the stats that I can run on my Secure64 server to see the tunnels, to see the blocking action, to see the IPs that are generating the traffic. So let's start this up. The first thing is I'm going to start my server. So here's my server. It's running this as a daemon, and I have my my tunnel endpoint of 10.0.0.1, and I have a password. Even though I'm a hacker, I've still got a password on my machine and I don't want anybody else using it. And then I have my domain. Now, I purchased that domain yesterday for £5.99. It lasts me for a year and there was no checks, nothing. It's about $8 for a year. I'm going to start that up. We won't see much on that screen at all, but I'm going to start that up. Remember, that's running on a £30, $45 Raspberry Pi. On these screens here, I'm going to start my clients. And just to prove that I don't have a tunnel in operation, I'm going to see if I have this UTUN5. And this will be created by the Iodine client as the tunnel is set up. So here, I can now start my client. You'll notice I've got Iodine again. It's running on my MacBook. I've got a few variables that I've set up. I've got my password again, and I've got my domain that's in use. Now that will go to my Secure64 server here, because my machine, my MacBook, is programmed to use this Secure64 server. And it will start up initially because I've disabled the detection of the tunnel on the Secure64. So I can prove to you this in operation without any extra configuration or manipulation or lists or anything like that. So let's start that up. I need a password for my machine, and we're now going to start that client up. Now you'll see lots of things go across the screen. The client is very clever. It detects how big a packet it can send across the network. So you'll see various different things in operation so it can work itself out. If I now go and look at UTUN5, I've got that tunnel operational now. So I've created a tunnel from my MacBook through to that server on the top left. And now I should be able to send a ping to that server. And that's going via the caching DNS server, the Secure64, with the detection disabled at this point, through to my server. So, and of course, all good demos, there needs to be one mistake. So we can see that the RTSC service is down at the moment. I just manually stopped it. So what I'm going to do is I'm going to start that service. I can't see any reports at the moment because the service isn't running, but I'm going to start that service. And what you'll see here is that we'll get a refused come up on this screen on my client, and we'll see the ping fail. So it takes a second or so because it's got to work out what's happening in the network and say, well, those are bad transactions. And now, once I've got everything operational, we'll see that we've got the refused command come back to the client. And you'll see the ping has failed. Let's just stop that because it's no point now. In the keyboard buffer, I've got a few other commands. So we can have a look at a log file and we can see that the tunnel is now being blocked. We can see the time, etc. But I can go further. I've got some commands that I can run here. So I can see some stats. Well, I've got one tunnel. That's what you're expecting, and it's being tracked and it's being blocked. I can see the domains that are being blocked, tunnel DNS, and how many transactions were going on. And I can also see the client. That was generating that. Thank you very much for watching. That's a quick introduction to DNS tunnels, but it shows the power of the platform. Please remember, DNS tunnels are bad things. They can be used to take data out of a network. They can be used to avoid paying for services, and they can be very, very expensive. The benefit of the Secure64 platform is that we can detect those tunnels via the algorithms that we've built into the platform. And just by a few commands, I've enabled that and got that operational. I didn't rely on lists like some other platforms do. This was all done via algorithms built into the platform. Thank you very much for watching.